This problem deals with some simple properties of logarithms. Part A asks to simplify the expression e to the a ln b. So as you recall from your algebra, this would be straightforward. If I could just, one of the properties of the logarithms allows you to bring the a to become the exponent of b if it's sitting outside the logarithm. So this becomes e to the ln b to the a, right? However, ln has a base of e, and so what happens here is when you raise the base to the log of that base, all you get is what's inside the logarithm. So the answer here would just be b to the a. Okay. Now, so let me just say one thing. So one of the properties of the logarithms, if this here is a, and I have here if log base a of some number b, the answer would just be b. This is what I'm trying to say. For part B, it says if b is a lot less than a, we're going to do some approximation and prove that ln of a plus b is approximately equal ln a plus b over a. Okay, well, if b is less than a, then I could say I could divide both sides by b, and then I know that b over a is a lot less than 1. So if I try to factor out the a out of this logarithm, so ln a plus b, if I factor out the b, trying to get that something a lot less than 1, so I can perform the approximation, which in this case is b over a. So I'm trying to create b over a. So to do that, I could factor out the a, and I would get 1 plus b over a, right? And this is the same thing. The product of two terms inside the log would just be log the first plus log the second. Okay, so ln a plus ln 1 plus b over a. Now let's take a look at what this guy is. So we know that from your calculus class, we can expand this in a Taylor series. So if you remember, if x, let me write down here, Taylor series. So from your calculus class, 1 plus x could be approximated in, assuming that x is a lot less than 1, right? Would be approximated by f of 0 so assuming that if I call let me call x here just to make it a little bit more simple. I will call x to be 1 plus b over a, right? And I mean x to be b over a, and so this expression just becomes 1 plus x, and x is a lot less than 1. So we know that a Taylor series expansion can be made on any function f of x, where this becomes equal to the value of the function evaluated at 0 plus the first derivative, because we are expanding about 0 here, the first derivative at 0 times x minus 0 raised to whatever order derivative I'm taking. So this is 1, and divided over the factorial of whatever order derivative I'm taking. So that's 1. Okay, and then this goes on to the second derivative, and then I can keep going up on these derivatives and on the powers of the polynomials and the factorials with the same power of the derivatives. In other words, this would be f double prime. The second term becomes, as I'm expanding around x equals 0, so this is technically became a Maclaurin series, squared divided by, so now second derivative meaning second order polynomial and 2 factorial, and then you can see the pattern here. Third derivative over 3 factorial times x minus 0 cube, and then the higher order derivatives, so on and so forth, which don't really matter because if x is a lot less than 1, higher order derivatives are just becoming smaller and they're hardly affecting the expression at all. They're not making any significant contribution to our expression. Okay, so with that in mind, in this case we have ln, right? So f of x, so in our case, so if we apply this to our case, we know that f of x is equal to ln 1 plus x, and so that means f of 0, if I plug in 0, I get ln 1, which is equal to 0, f prime of x 1 over 1 plus x, and then f prime at 0, just evaluated at 0, is 1, and I can keep on going, but again I don't require that many extra derivatives because it's an approximation. So this is minus 1 over 1 plus x squared, and if I evaluate this at 0, I will get minus 1, so on and so forth. So now that means plugging this back, so that means ln 1 plus x is equal f of 0, which is 0, plus f prime of 0, which is 1, times x over 1 factorial. I'm filling into the Taylor series now, plus f double prime, which is minus 1 over 2 factorial. 2 factorial is just 2x squared, so on and so forth, right? But x is b over a. Okay, so if I just take this up to the first order, I could ignore everything else after this, and so ln 1 plus b over a would just be b over a, approximately b over a. So if I plug this back into my expression, let's call this expression number 1, so plug in 1, I would get ln of a plus b would equal to ln a plus ln 1 plus b over a, which turned out to be over a. And now if I take all this and put it back into my am I done here? What's sorry, what was the question? Yeah, we are trying to prove this, and we did. So so that means ln a plus b is ln a plus b over a. So this is the desired result. This concludes the question. Was there anything else? No.